Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, here we go. Let's take a look at the homework from yesterday. First, we have our M&Ms, which goes into a little bit of detail, filling in some of the details for how you find circumference of a circle, and it's going to give you the formula for finding the area. Is it area of circles? I don't see where it's in here. Oh, there it is, area of circles. So we technically haven't gotten to this yet, this part of the lesson, but we've talked about it. I'm pretty sure you've gotten it in previous years, so we can go ahead and work with it a little bit. First of all, circumference, to find the distance around the circle. Remember, it's approximately a little bit more than 3 times the diameter, and that's where the pi comes into play. So you measure your diameter, multiply times pi, and you'll have your circumference, which will end up getting rounded off at some point since pi is irrational. And in today's lesson that we're going to do, we're going to find out some of the logic behind this area formula, where area of the circle is equal to pi r squared. So you take the radius, they give you the diameter, you take half of it, square it, and then multiply it times pi, and that will tell you the number of square units that fill in the inside of that circle. So with this as your formula here, you're able to do some of the homework today, even though yesterday in our lesson I didn't specifically give you this formula. I'm saving it for today. But like I said, I think you've already seen the formula anyway. So here we go. The circle shown at the right has a diameter of 20 centimeters, which means that the radius must be 10 since the radius is half. So what measurement do you need in order to find the area? Well, for this formula, you need to know the radius and you need to square it. So that makes it kind of nice here because 10 squared is easy. That's 100. And so sometimes you'll see it written here like 100 pi, where you don't actually figure out what 100 times pi is, even though that's what this answer wanted. But sometimes you'll see it written in, this is called in terms of pi. If you just rounded off pi to 3.14, then that's a nice and clean 314 square centimeters. But if you do the actual value of pi, you take 100 times pi, and now it's 314.15, maybe 0.16, or maybe rounded up to 314.2, depending on where you want to round it. So technically the area is actually a little bit more than 314, but it would round down to 314 square centimeters. So that's our answer. And now we've got 3 different circles with 3 different measurements given, and our job is to find both the area and the circumference of these circles. Well, the circumference part, that's pretty straightforward. You're just going to take pi times the diameter, pi times 15, ends up rounding off to 47.1. The area, if I think this one I multiplied just times 3.14. So if that's what you multiplied, what would that end up being? The radius for this one is going to be 7.5. So you square that, and then you multiply that times pi. And if you take pi as 3.14, you get 176 and 625 thousandths. If you multiply times the actual pi, let's go 7.5 times 7.5, that's 7.5 squared is 56 and 25 hundredths. Then multiply that times the actual pi. I just rounded it off to 176.7, but notice how this is a little bit more than that. So you could have gotten either one of those answers depending on whether you had a pi button on your calculator. Same thing here, 9 squared is 81. 81 times 3.14 gives you this amount in red. 81 times the actual pi is going to give you this, which I rounded off to 0.47. Maybe we could have rounded that off to 0.5. And then the circumference, what does that end up being? 18 times pi. 18 times pi is 56.54. Either one of them, you could round it off to 56.5, and they would essentially be the same. For problem C, this is the reverse of what we were doing before, wasn't it? Or maybe not. Having a circumference of 314 centimeters is nice because we know we multiply pi times diameter to give you 314. So you might as well just use the 3.14 rounded off version of pi here. And you take 314 and divide it by 3.14, and you're going to get 100. So the diameter is 100 centimeters, which means that the radius has to be 50 centimeters. So if the radius is 50 centimeters, don't we need to find the area of that? I guess I never finished this process. Oh no, we just need to find the radius for part C. But we could then take that and find the area of this circle. And that's actually probably the most complicated thing that we will do in this 7th grade math is you're giving us a circumference. You have to figure out what the radius is based on the circumference formula. And then once you know what the radius is, then you square it and multiply it times pi again to declare what the area is. All right, this we didn't really spend a lot of time with this. I don't think, mainly because it was really hard to do with distance learning. Doing it in class where you have little see-through paper and you can make your marks and you could use in your teams multiple people to help construct these triangles, much easier than trying to do it on your own. But here's the basic idea. You take a line that's 4 centimeters long and another one that's 5.2 centimeters long, and you got to manipulate those. I don't know how you're going to manipulate those on your paper without like actually physically cutting out the piece of paper with the line shown on it. So basically you're just going to cut out a piece of paper, a long thin rectangle that measures one 4 centimeters and the other one 5.2 centimeters. So I can do it manipulating here, like with my rulers and such. But then the last part, getting that 45-degree angle somewhere within this triangle. So basically what we do here is, you could take your protractor and you can measure it, put the origin on this vertex, and then make sure that it reads 45 degrees. Or my super cool protractor here, let's get it up to 45 degrees. Oops, oh, it's there, 45 degrees. Now I can form that angle, and now I can use this to construct it. Does that look like it's 45 degrees? Yes, it is 45 degrees. So your triangle should look something like this. It might be rotated or inverted, but for the most part, one angle that's 45 degrees right here, one side that's 4 centimeters, one side that's 5.2 centimeters. And here we are, some of the rules associated with angles. You got complementary angles that always add up to 90 degrees. You've got supplementary angles that always add up to 180 degrees. And you've got vertical angles that are across from each other that have the same measure when two lines intersect. So we know that these two angles are forming a right angle because you can see that box right there for the right angle. So that means that they add up to 90 degrees, which makes them complementary. So what do you add to 68 to give you 90? It would be 22 degrees. So this must be a 22-degree angle. We know that these two angles form this straight line, which means that they form a straight angle, which is 180 degrees. So B must be whatever 180 minus 36 is. And that means it must be a 144-degree angle. So those are supplementary angles. Here, we know that 66 has to match this 66, so that part's easy. And we know that this angle here is supplementary to this angle. So 180 minus 66, that could be 1710, that's going to be 14, and that's going to be 17 minus 6 is 11. So that must be 114 degrees, which means this one would be 114 degrees. And then problem D is the same as that one, just slightly different angle measures. They're complementary, so that has to be 30 degrees because that adds to 60 to make 90 degrees. All right, the Shones family orchard produces 130 pounds of fruit per tree using traditional farming techniques. They would like to change to a biodynamic farming technique that will increase their yield by 20%. Changing techniques will cost money, but the fruit crop will be larger. Help them decide if they should change by calculating how much they will be able to grow 2 different ways, using 2 different multipliers or scale factors. So remember, 20% is the same as 20 hundredths, which is the same as 0.2, 2/10, 20 hundredths. So you could multiply 130 times 2/10. This is going to tell you how many more pounds of fruit per tree you're going to grow. If you choose this to be your multiplier, this is your 100%, which is your 1, plus your additional 20%. So the current yield, what they've been doing using their current traditional techniques, plus the additional 20%, means that your multiplier is going to be 120%, which is 1.2. So when you multiply 130 times 1.2, what you get here is the total number of pounds that will be created using the biodynamic technique. Now, we could have just used this technique here, or used this multiplier here, I should say, and then added it to the 130. When you add 26 to 130, you get 156 as well. So, you know, it doesn't really matter which way you go. The fact is you can do it both ways. Whatever situation seems the most logical for you to do it in the fewest steps, choose that multiplier and solve the problem that way. And Howie and Steve are making cookies for themselves and some friends. The recipe they have, it makes 48 cookies, but they only want 16. They have no trouble reducing the amounts of flour and sugar, but how do you figure out the amount of butter? So the recipe for 48 cookies requires 1 3/4 cups of butter. So we need to figure out the scale factor. So 16 is 1/3 of 48, and 48 is 3 times 16. And so if we take 1/3 of the sugar and 1/3 of the flour, we're also going to take 1/3 of the butter to figure out how much butter we need for 16 cookies, which is 1/3 the total recipe. So how do you find out 1/3 of 1 3/4? Well, that's a multiplication problem. So you could just say 1/3 of, we want to change that to an improper fraction, 7/4, which becomes 7/12, which is a little bit more than 1/2. So you just do a little bit more than a 1/2 cup of butter and you should be good. Or you could technically use proportional reasoning here, but I think this technique is going to be a little more complicated. So our understanding of scale factors and using them for proportional reasoning sometimes is a lot easier than setting up the proportion. And that's it. That's our homework. So hopefully you understood that fairly well. Today we're going to get into the second part of the area of circles formula and why it works. And so yeah, we'll move on to that next.
Hey, feeling good, like I should. When in dark, walk